Hey guys, this is homework 7.7 on multiplying and dividing rational expressions. So the other day we learned about simplifying rational expressions. Multiplying and dividing them is not much different. It's just that now instead of having just one fraction, we're going to have multiple fractions. So in the note section of your handout, all the examples we do here are going to correspond to the examples on the handout that you were sent also. So in the note section, I'm going to give you a minute to write down these notes. So multiplying, you can divide out any common factors from all numerators with all denominators. Take a second to write that down and to write the example. Okay, so let's try this example together. So if you notice now, I have two fractions that are being multiplied together, and I also, everything's in factored form here. So this is just a quick example to show you what we mean by multiplying, and then we'll do some more examples where we actually have to factor. So everything's already in factored form, so notice everything's being multiplied together within each fraction and between the two fractions. So we have x plus 2 times x minus 3 all over 5 minus x, and then that whole fraction is being multiplied by x minus 5 times x plus 4 all over x minus 3. So again, everything here is multiplication. So if I want to multiply, I can divide any common factors out from all numerators with all denominators. So even though x minus 3 is in the first fraction in the numerator, I can divide it out with the x minus 3 that's in the denominator of the second fraction, as long as I'm dividing. So one's in the numerator, one's in the denominator. Okay. The only other common factors I see are that relationship between the x minus 5 and the 5 minus x. To remember, they're negative reciprocals, so they actually divide out to -1. So I'm going to just put that -1 here as multiplication to remind myself. So now in the top, I have -1 times x plus 2 times x plus 4. And in the bottom, I only have a 1 left, and I don't have to write that in the bottom. So this is the final answer here. Okay, so underneath that, again in the notes section, we're going to write dividing. Keep, change, flip to make it into a multiplication problem. So you guys have done this before, but now we just have expressions in numerator and denominator rather than just a whole number. Okay, so I have in this example, I have 2x divided by x plus 3 divided by 4x squared divided by x plus 3. So in order to start dividing things out, to simplify, I need to change this to multiplication. So I'm going to do keep, change, flip. So I keep the first fraction as it is, I change the sign in the middle, and I flip the second fraction. So I get 2x over x plus 3 times x plus 3 over 4x squared. Keep, change, flip. Now I can actually start simplifying this. So again, just like multiplication, anything from any numerator can be divided out with any denominator. So I see the x plus 3's are common factors, so I can divide those out and they just become 1. And then the 2 and the 4 reduce to 1 over 2. And then the x and the x squared leave me with just an x on the bottom. So when all said and done, this simplifies to 1 over 2x. And that is my final answer. Okay, let's start with the first example that's below or next to the notes section. And here you see we have a multiplication problem. Notice that everything in here is a monomial. There are no binomials, trinomials, polynomials, because I don't see any addition and subtraction breaking up terms. So everything here is actually only one term, which is nice because now I have free range to start dividing things out. So like we said before with multiplication, any numerator can be divided out with any denominator. So let's see, what do we have here? Okay, so I see we have a 6 on the numerator and a 9 in the denominator, and that reduces If I divide the top and bottom by 3, that reduces to 2/3. And then I say I have a 10 in the numerator and a 4 in the denominator, and if I divide by 2, that reduces to 5/2. And then I can keep going, and I see a 2 in the numerator and a 2 in the denominator from what I just simplified, and that reduces to 1. So as far as the whole numbers go, I have a 5 in the top and a 3 in the bottom. If it's easier for you, you could have multiplied the 6 and the 10 together in the numerator and the 4 and the 9 together in the denominator, and then just simplified those numbers if this is like too much dividing out for you and it gets confusing. Okay, so I know I'm going to have a 5 in the top and a 3 in the bottom, and I'm going to figure out now with all of these x's and y's. So you can really do this however you want. Like I said, you can multiply the x's together that are in the numerator, the y's together in the numerator, and then do the same thing for the denominator, and then just simplify everything at one time, or you can keep crossing out like I did with the whole numbers. So I'm actually just going to keep going with the method I was using, and I'm going to divide out the x squared and the x to the 5th, and that leaves me with x cubed in the bottom. And I'll actually start writing that down here. And then I have y cubed over y squared, and that leaves me with just y to the 1st in the top. So I'll add that to my answer. And then in the second fraction, I have x to the 1st over x to the 5th, so that leaves me with x to the 4th in the bottom. And then I have y squared over y to the 7th, and that leaves me with y to the 5th in the bottom. And now you see we have a little bit more simplifying to do here. So I have 5 over 3. And then with the y's, y to the 1st over y to the 5th, that leaves me with y to the 4th in the bottom. And then these x cubed and x 4th, if I multiply the variables, I add the exponents, so that leaves me with x to the 7th. And then I have that y to the 4th. So this is my ending solution. Again, I want to repeat, you could have, since everything here is monomials, it's all just multiplication, you could have multiplied the 6 and the 10 in the top, and all the x's in the top, and all the y's in the top, and then you could have done the same thing with the bottom, and then you just would have had one fraction to simplify. That may be easier for you. Okay guys, here we have example 2. One thing I want you to notice is that now these are not monomials. I have binomials and trinomials, which means I have to factor. Remember, I can't just start crossing out numbers that look the same or variables that look the same. Everything has to be multiplied in order to be divided. So what I'm going to do is I'm just going to start factoring out anything I can. So I'll start with the numerator on the left side. X squared minus 4. Well, I notice that's a binomial. And no matter what, I always look for GCF first. There's no GCF between x squared and negative 4, but it's a binomial, so I look to see if I can use difference of perfect squares, which I can here. So when I factor that out, I get x plus 2 times x minus 2. That's what we want, multiplication, x plus 2 times x minus 2. In the denominator, I have a trinomial. Again, I look for a GCF. No GCF there. So now I'm going to find two numbers that add to the middle term and multiply to the last term. And so they have to multiply to negative 6 and add to negative 1. So we can use 3 and 2, and the 3 should be negative since it has to add to a negative 1. And that makes the 2 positive. And just to check myself, negative 3 times 2 is negative 6, so that works. Now for the second fraction, I'm going to keep going. And on the numerator, I have 3x squared plus 15x. And I look for a GCF, and I see I have a GCF of 3. And I can also take out an x. Okay, so now I'm left with x plus 5. And in the bottom, I have 6x squared minus 12x. And again, I look for a GCF first. And I see I can take out a 6, and I can take out an x. And what am I left with? I'm left with x minus 2. Okay, so now you should see that we have some common factors between the numerator and denominator. So let's see, what can I do from here? Well, I have an x minus 2 in the top, and I have an x minus 2 in the bottom. I have an x plus 2 in the top and an x plus 2 in the bottom. Then I have an x plus 5 in the top and an x minus 3 in the bottom, so there's nothing I can do with those. But then I see I have 3x and 6x, and those can be simplified as well. 3 over 6, if I divide both by 3, that gives me 1/2. And then x to the first over x to the first is just 1. So it looks like I am left with, in the numerator, x plus 5. And in the denominator, I'm left with a 2 times and then x minus 3. And this is the simplified version of that original multiplication problem. Okay, guys, this is example 3, and we have one more example after this. So now if you notice, this is division and not multiplication. So we have to use our keep, change, flip here. One more thing I want you to notice is, again, these are all monomials. There's no addition and subtraction, so that's nice and easy. It means we can just start dividing things out, and we don't have to worry about factoring. Okay, so first thing I'm going to do is I'm going to do my keep, change, flip. So I'm going to keep the first the same, change the sign in the middle, or the operation in the middle, and flip the second fraction. So that means I have 30y to the 6 over 20x cubed, so that doesn't change. Then the operation in the middle becomes multiplication, and then the second fraction flips, 8x over 24y squared. Okay, so now I'm going to start dividing things out that can be simplified or reduced. Okay, well, 20 over 30, if I divide both the top and bottom by 10, again, you can use your calculator to simplify the fractions. That will simplify to 3 on top and 2 on the bottom. And then the 8 and the 24, if I divide both 8 and 24 by 8, then that leaves me with 1 on the top and 3 on the bottom. And then if you notice, within each fraction, between the numerator and denominator, there are not the same variables, but if I look across to the other fraction, I notice like y to the 6 is on the top, is in the numerator of the first fraction, and then y squared is in the denominator of the second fraction. So that means I can start simplifying those across any numerator with any denominator. So y to the 6 over y squared leaves me with y to the 4th in the top, and x to the 1st in the top with x cubed in the bottom leaves me with x squared in the bottom. Okay, so then that means in the top I have 3 y to the 4th. I also have a times 1, but I don't need to write times 1. In the bottom I have a 2, an x squared, and a 3. So 2 times 3 is 6, and then x squared. And if you notice, now I even have a little bit more I could simplify, because the 3 and the 6 can be reduced to 1 over 2. So 1 times y to the 4th is just y to the 4th in the top, and 2x squared in the bottom. Okay, guys, just one more example. Okay, example number 4. This is our last example, and again, it's division. So since I see it's division, I have to do my keep, change, flip first. So I'm going to keep the first fraction the same, change the operation in the middle, and flip the second fraction. So now that means I have 9x squared minus 1 over 3x squared plus 7x plus 2. Change the operation in the middle to multiplication and flip the second fraction. So I have x squared minus 5x minus 14 all over 5 minus 15x. Okay, so far so good. So now that it's multiplication, I just need to factor everything because these are not monomials. I can't just start crossing things out. So I'm going to start with the first fraction. 9x squared minus 1. I do not see a GCF there, but I notice it's a binomial, so I should see if it's a difference of perfect squares. And it looks like 9x squared and 1 are both perfect squares, and it is a difference. So I'm going to factor that guy out, and I get 3x minus 1 times 3x plus 1. Okay, so now in the bottom, I look for a GCF. 3, 7, and 2 do not have anything in common, and then the 2 doesn't have an x, so I can't bring an x out. So this is a trinomial where there's no GCF, and the leading coefficient, 3, is bigger than 1. So that tells me I need to use garbage method. Okay, I'm just going to do my garbage method off to the side because there's like a few steps to it. So I have 3x squared plus 7x plus 2. Okay, so garbage method, I multiply the 3 and the 2, or the a and the c term, and that gives me 6. And then when I set up my two binomials, I need to remember to keep that leading coefficient, which is 3, in both of them because I multiplied that extra 3 in. And then remember, I'll get rid of it as taking out the garbage. Okay, so I need two numbers that multiply to 6 and add to 7. So that's not too bad, just 6 and 1. And 6 plus 1 is 7. 6 times 1 is 6. And now I notice 3x plus 6 has the garbage because I can divide out 3 from both terms. So that leaves me with x plus 2 times 3x plus 1. And now I'm going to write it back in my expression because it's too messy to just like start writing each step. You might forget to take out the garbage. That's why I like to do this on the side. Okay, so I'm going to write that up here. X plus 2 times 3x plus 1. And then I'm actually going to just get rid of this so it doesn't confuse us at all. Okay, so now if you look at the second fraction, in the second fraction we have x squared minus 5x minus 14 in the top, and in the bottom we have 5 minus 15x. So I'm going to start with the top. I look for a GCF there, and I don't see a GCF between all three terms. And I notice it's a trinomial, so I am going to look to add to the middle term, multiply to the last term. So set up my two binomials. I have x. And let's see, we need to, again, add to the middle, multiply to the last. So we can use 7 and 2. And negative 7 plus 2 is negative 5. Negative 7 times 2 is negative 14, so that works. Now in the bottom, I notice it's a binomial. First thing I always look for is GCF. 5 and 15 have a common factor of 5, so I'm going to divide that out of both terms and keep it out front as a GCF. And I have 1 minus 3x. Okay, so now let's get to work on dividing out common factors. So what do I see that looks the same in the top and the bottom? Well, I see a 3x plus 1 on the top and bottom of the first fraction, so that divides out to 1. And then I see x plus 2 in the bottom and x plus 2 in the top. And then I see an x minus 7 and a 5, and there's nothing I can do there. But notice I see a 3x minus 1 on the top left and a 1 minus 3x on the bottom right. So remember that structure, they're negative reciprocals. Positive 3x on the top, negative 3x on the bottom, negative 1 on the top, positive 1 on the bottom. So these guys divide out to negative 1. And remember, it doesn't matter if you put that negative 1 in the top or the bottom. Just remember it's multiplied, not like subtracted by 1. Okay, so let's see what we have left in the top. We have x minus 7 in the top, and in the bottom we have a 5 times negative 1, so that's just negative 5. So this would be our ending simplified version of that original division problem we had. Again, remember you could have put the negative 1 in the top, so your answer may have looked slightly different, but what we're looking for is an equivalent solution. Okay guys, that's all for now.